Hey guys, so I'm going to be going over the basics of TypeScript and kind of the things that I use, the features I use on a daily basis. So the first thing you want to do is go ahead and install TypeScript on your computer. And to do this, you can just do npm and just globally install it like this. And spell TypeScript like that. Make sure you spell it right. And so I already have this on my computer, so I don't need to run this. But after you do that, you now have TypeScript. And what you do is you can code in files, and for example, the extension is different than JS files, so it's .ts for TypeScript. And what you do is you would write code, TypeScript code, and then you're going to compile it to JavaScript code. So for example, let's say I want to create a variable called Bob, and just a string, hey, I'm Bob. So this is actually a TypeScript variable right here, and it infers the type based on what's over here. So this is a string right now. I was going to see if it gives us any kind of like type annotations or whatnot, but it doesn't look like Visual Studio Code's going to show that. But it is a TypeScript variable now. And what we're going to do is I'll show you how to compile this. So if you use TSC, this will be the TypeScript compiler, and I'm just going to feed in main.typescript. And so let's say I wanted to add a console.log so we can see Bob. Let's say I wanted to run this code. I would first compile it, and what's going to happen is it's going to turn this into a JavaScript file. And we can come over here and we can look at main.js, and this is what it created. So right here we can see it looks almost identical, but it changed it to a var. And that's because, and this is a setting that you can tweak with, which we'll talk about later, but by default it does not do the latest JavaScript features, for example const and whatnot. And so for example, if I have like maybe const bob2, so here I have like a little bit of a function, and now we're going to compile it. If we come over here, you'll notice how it changes that arrow function to a function like this. Okay. So let's come back and go over some other things. Not sure why this is red. It says cannot redeclare block scope variable. I don't know what it's talking about there. I think we can just ignore that. So that is how you compile it, and then to actually run this, what you would do is it's converted to JavaScript code, so you can do whatever you like with the JavaScript code. For example, you could run it with Node, and we can see it console logs, hey, I'm Bob. So as we're coding any of this stuff, at any time you could compile it and then run it with Node if you wanted to. Alright, so let's dig into some more stuff. So let's get rid of this stuff. So variables. You just saw me declare a string. You can also have other things, right? You can have numbers, and you can have decimals if you want to, and you'll notice that this type is, as I said, it's inferred. So we can also infer objects. So I might have a variable in here, x, y, right, and it automatically knows the type of this object. And here's what I was talking about, so we can see the type of this thing. So this is an object which has an x, which is a number, and y, which is a number. So notice how you don't call these ints. And this also means if I do decimals like that, this is also a number. So we can see x and y are both numbers still. So numbers represent both integers and doubles or floats, if you will. So that's how you do variables. The other thing with this is sometimes you can also like explicitly set it. So here's how you would define a variable in TypeScript explicitly. So here's the type. So you do a colon after the name and then the type of your variable. In this case, it's a number, so we set it like that. And you can do the same thing with an object. So here's how you would do an object. You could say x, which is a number, and y, which is a number, like that. Now sometimes when you declare an object like this, you don't always, and let me show you guys actually before I talk about that, how you can do other. The other way to define an object like this is to create an interface. So my interface could be my object, and and inside of that I would like to have these fields, and I could set it like this. So I have what looks like an object, and it's an interface. So we have the type, and you'll see this is the name inside of here, and then this is the value or the type of it, and you'll match up. So then this is nice because then I could create a second object, and then I could have it as that same type, and maybe the x is a different value and y is a different value. So I can reuse this interface across multiple objects. And so this ensures that this type is a number. So if I were to try redefining this, I could redefine it to 1. I could do it to a float if I wanted to, but it's going to cause a give us a little error here and tell us, hey, you can't do that because it's of type number. I don't know. Let's see if I do true. Yeah, same thing. And false because these are booleans. So if I were to say let, and of course, for example, we said a is a number up here. We can't redefine that to a string, and that's for two reasons. One, it's const, so we can't redefine it, and the type is a number. But if I were to say let this to be, for example, true, we have inferred this is a boolean, even though we have not explicitly said it. It even tells us right here. So if I were to say is dog is now 1, again, we're going to get problems with all this. So what if I want to add, a lot of times when you're creating an object, you might add a field later. So object dot, I don't know, z is equal to this number here. And you'll notice it doesn't like it very much. And the reason for that is because we didn't specify in this interface that this is the that this object could possibly have a z. So what you need to do is add z to the number like that, right? But then we're going to get a new problem. Up here we didn't define this object with z in it. So we need to have z be optional, because this object might not want to have a z property, but this one might. So to make optional, you add a question mark. So now everything is happy. So we can optionally have a property called z. And you'll notice this also checks against, for example, null. I actually don't know by default if it'll check against null, but if we look at my object 2, so it knows that object 2 does not have a z. So if I were to add 5, okay, so it's not checking nulls. So if it was checking nulls, this is a setting that you can add. It would be able to detect that object 2 does not have a z in it right now, and you can do something like this. But anyway, that's a setting that you can turn on and off. That's pretty nice. And you'll notice by default, I think it's whatever global TypeScript settings you have, since we're using the global TypeScript. But you can create a little kind of like configuration, kind of like ESLint or whatnot. Alright, so that's how objects work in adding properties. This is the optional, and you can have as many optionals as you want. Let's go over how functions work. So I can create a function, we'll call it my function. Nope, let's call it add. And it takes x and y and it adds them together. Now we need to specify the types of x and y. So this is going to be a number, and this is going to be a number. Now it's going to infer what the return type of this is. So you can see it takes a number and returns a number. So if we wanted to, we could specify the type of this. So x takes two parameters, x, which is a number, y is a number, and then what does it return? Well, a number. It infers it automatically for us in this case, so we don't have to add it. Also, you might not really like adding, let's delete that real quick. And we need to delete that, okay. So you might not like just like cramming that definition here. So what you could do also is make a separate type called maybe add function. And so this is a type, so this is good for reusing things and also just for space. and I could specify the type of this. And also notice if I change what this returns here, it's going to tell me, hey, I'm not expecting a string to be given back, I'm expecting a number. So it'll catch these things for you, which is really nice. We'll leave that in for now. And this is a number. And also now when I add number, or call add, for example, I have to pass in numbers and it enforces this. And again, we know this works for floats, but if I were to add, I don't know, my object, I just call it object. Whoops, there we go. It's not going to like it, and we can read the error. Argument of type my object is not assignable to parameter type number. So basically what TypeScript is doing in all these cases is it's just making sure all the types match with what it's expecting the type to be. And we could get fancy if we wanted to, and we could have a function as a parameter or an object as a parameter. So a lot of times I like to destructure things. So let's say add 2, and we're going to take an object as a parameter, and let's say we have a and b, and then we're going to add a and b together. So again, here's how you can specify this guy right here. So we're destructuring this, but it doesn't matter, it's still an object. So a, which is a number, and b, which is a number. And we could also, if we didn't want to destructure it, we could just say this is the nums object and say nums.a, nums.b. So both of those work, and that's how it works with destructuring and the types and whatnot. And TypeScript will handle and supports all of these things. That basically anything you can do in like the newest JavaScripts, you can basically do in TypeScript as well, like the spread or destructuring or const let, these functions. I haven't had any problems where there's features in TypeScript which are not working. You can even do the at, these are the decorators like this, so declarate, those thingies. You can also, they're experimental, so you have to turn a certain flag on, but pretty much everything you can do in JavaScript you can do in TypeScript as well. But basically it's basically JavaScript. It feels very similar. I picked it up very fast because you're basically just adding types. So everywhere you have variables now and whatnot, you just like specify the type. Alright, so the other thing I wanted to go over is we saw how to add functions and create functions. A lot of things I use require unions. So for example, I can have one of two types. So let's say I have, we'll call it maybe number. So it's 5 here, but maybe down the line I want this to be a string. So I can say number or string. So this pipe operator will allow you to concat these, not concat either. So it's either a number or a string. So in this case, I could now set this to be hello, and it's not going to be mad at me. But it will be mad if I, for example, did false, because we know it can never be a boolean. And I can do this as many times as I want though. I can add boolean as one of the types. So maybe num can now be false. And you can union types as well, so it could also be an add function. So maybe num can now be equal to add, and it's not going to be mad at me because this is an add function and I set it equal to that. But if I got rid of that type, it now would be mad at me because I can't set this. So unions are really nice. The other thing that goes with unions are with objects. So I have my object here. I could create another interface called, we'll just create two new interfaces. So I'm going to call this dog, and let's say the dog barks, and it's going to be a string, and I'm going to create an interface cat, and it's going to purr, and that's a string. If I wanted to, I could concat these into one type, And the way you do that is, I'm going to create a dog cat, which is equal to dog and cat. So what this type is, and we can look at it, it's not going to show us, that's a shame. So let's create a dog cat. It's going to be of type dog cat, and it's going to be a bark, and it can have a purr. So that's what it did, exactly what you think it did. So it took this object and this object and kind of just smashed them together. So now it can have a bark and a purr. And if I ever change this, so for example, I just got rid of, it no longer has a property called purr, it just, goes down the line and it says, all right, so dog cat can no longer have purr. This object is of the type dog cat, so it cannot have a property called purr. So that's pretty nice. So you can smash those interfaces together, and you can either, you can get crazy if you want to. I can say it can be of this type, or it can just be a number or whatnot. So here I can say let, and I could have dog cat is equal to 5. I don't know, something crazy, right? So I can set this to a number, or I can set it to an object that equals this. And then basically, to know what value that these things take, you just have to do if statements. So a lot of times I'll do dog cat, and I'll get the type of it, be like, all right, is that equal to, and whatever, and check what the quality of it. I actually don't know if this is called number or integer or what to put here, but for strings, I know you just do string. So for example, if it's a string, console.log, you're a string. So with the unions, what you'll end up doing is have to do this to be able to make sure the type is right. Okay, another thing is sometimes you have to cast the types of variables or whatnot. So take this weird dog cat thing. I want to pass it to my add function. Dog cat and dog cat. Will it allow it? Okay, so it allows it, alright, no problem. But sometimes you have in JavaScript where it doesn't like it, or I don't know, if we change this to not be able to accept a number. Well, actually, so here's how you cast things. You use, there's multiple ways, but the way I like to do is with as, and it doesn't like as, so another way I can do is as any. So obviously I shouldn't be able to pass the add or dog cat to add because it's not a number. But if I wanted to, I could force Typescript to let me. So as lets me redefine or cast things. So it wouldn't let me cast it to a number, which makes sense because this should never ever be a number according to this. But it will let me cast it if I have this. Cannot be heard to type number. Okay, it still doesn't like it for some reason. I was expecting this to let me. Maybe if I do that. Okay. So interestingly enough, so look what it did there. It was actually detecting that I have not made this into a number yet. But as soon as I do that, it allows me to cast it to a number here. That's kind of interesting. But anyway, that's how you cast things. So this comes in handy once in a while when your types aren't doing what they want them to do, and you can cast them to things. And at any time, if you want to just force things to work, you can use this keyword called any. And that means it's of type anything. So I can create like a function that does anything. And one of its parameters is going to be just x, and it's going to do anything with it. And let's say I just console.log x. That's all it does. So does anything can now take as a parameter any number of things. So it can be a number, it can be false, it could be a string, it could be an object, it could be another function, doesn't matter. So we could do that, turns 5. You can pass it anything and it handles it. So that comes in handy when like TypeScript doesn't always behave and gets in places where you're like, hey, that should not be giving me a type error or something. I just use the keyword any, or sometimes it's really hard to try to get the types right, and I just use that. But yeah, this is a little bit of an introduction to TypeScript. That's pretty much all I wanted to go over in this video. And the next one, I want to go over how you can like set up TypeScript with a TypeScript configuration file. That way you can get it to compile things in different formats, or get it to compile in different ways, in different ES6, ES7 sort of way. And then also go over how to use this with React. But before I end, let's just convert this over and see what happens. I want to just like see what it does to this stuff. So we can see it changed everything to just like functions and vars, because that's what it's set to do. And let's see if this runs. I guess it just console logs because this thing at the very bottom. But yeah, this is it for this video, guys. Thanks for watching.